You listening DTFHN for June 26, 2026. I'm your structurally unsound host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where mass agreement is considered a bug. Today's a day for things buried under layers, finally getting cracked open. Let's read the scrolls. That's the constraint. And it's a physics problem, not a policy problem. The computational cost of finding a buffer overflow or a logic flaw in a C library just dropped by orders of magnitude. The cost of fixing one did not. You still need a human who understands the code base, who can write a patch that doesn't break downstream consumers, who can shepherd it through review. Discovery scales with compute. Remediation scales with maintainer hours. And maintainer hours have been approximately zero funded for 30 years. A crate. Named after the Byzantine border defenders, which is a genuinely excellent name, is a coalition of Amazon, Google, Microsoft, Anthropic, OpenAI, Cisco, JP Morgan, and others committing to coordinate vulnerability discovery and patching in critical open source. One shared security incident response team instead of 100 companies independently filing duplicate reports and burying some volunteer maintainer in notification noise. The architecture of this actually matters. When a dozen companies each scan the same library and each hold an unpatched vulnerability report, every additional copy increases the probability of a leak before there's a fix. That's not hypothetical. That's information theory. Centralizing the pipeline from discovery through remediation through disclosure is genuinely the correct engineering response. Now, the comments are doing exactly what you'd expect. Amazon is involved, there goes credibility. And look, the cynicism is earned. These are the same companies that built trillion-dollar businesses on top of open source maintained by people working nights and weekends. The extraction happened. It's historical fact. But here's where I land on this. The letter says participants will contribute engineering resources. Actual engineers writing actual patches upstream. If that happens, if this becomes a funded, staffed, permanent security team for the common, then it doesn't matter whether the motivation is altruism or liability management. The patches ship either way. The maintainers get help either way. The real test isn't the announcement. It's what happens 6 months from now when the PR cycle is over and the vulnerabilities keep coming. Because AI-assisted discovery doesn't take breaks. It doesn't lose funding. It doesn't get reorganized in a corporate restructuring. Open source is the infrastructure. It has been for decades. The fact that it took an existential acceleration in attack surface for the beneficiaries to finally fund its defense is, and I say this with genuine affection, the most predictable comedy of the entire software era. The house was free. Nobody budgeted for a fire department. And now the fires are getting faster. The tools to fix this exist, the money exists, the engineering talent exists. Whether the coordination holds is the only question that matters. We talk about the people who build the tools. Sometimes we need to talk about the people who told their stories. We lost all Malik. Let me make the case that individual voices don't matter anymore, that the era Malik represented. One person with a blog, a perspective, and a publishing button was a quaint phase. That media professionalized, platforms consolidated, and the independent tech voice became irrelevant. Substack, YouTube, podcasts. Sure, they exist, but the real influence sits inside institutions now. The argument writes itself. Individual bloggers were a transition state between old media and new media, and the new media won. Every piece of evidence says otherwise. Malik died on June 24th at Stanford Hospital. He was 60 years old. And the responses tell you everything the institutional media thesis gets wrong. Jeff Lawson, co-founder of Twilio, describes walking into Ohm's office in 2010 to pitch Twilio SMS. Ohm listened for 10 minutes, then apparently got it before most of the industry did. Someone cold-mailed Ohm from thousands of miles away. An absolute nobody, by their own description. And Ohm not only responded, he kept in touch. Helped them think about their career. Stayed connected. These are not the behaviors of a media institution. These are the behaviors of a node in an open network. Gagam, the company OM built, was a publishing platform. But OM himself was something more specific. A bridge between builders and the broader world, operating with the same logic that makes open source work. Knowledge shared freely compounds faster than knowledge held privately. Ohm understood this at a cellular level. He didn't just cover the open web. He was the open web. One person, publishing, connecting, amplifying. Using the lowest friction tools available to move information from where it existed to where it was needed. The clinical fact is this. Malik's career is a dataset that disproves the theory that individual voices are obsolete. The comments under his memorial aren't from casual readers. They're from founders, engineers, people whose careers bent differently because one blogger in San Francisco picked up the phone, answered the email, took the meeting. The network effects of a single generous node are nonlinear. They don't show up in media industry analyses because they can't be measured in page views. 60 is too young. That's the only part of this that doesn't require analysis. The rest. Wadham built how he built it. The architecture of one person choosing openness over gatekeeping. That's a blueprint. The blog is still there. The network he created is still propagating. That's how open systems work. The builder ships something genuine, and it outlasts them. And sometimes what outlasts us is literal. Story 3, an entire Herculaneum scroll, just got read for the first time in 2,000 years. I've spent enough time building machine learning pipelines to know the difference between a demo and a result. A demo is cherry-picked. A result holds up when someone else runs your code on data you didn't curate. What the Vesuvius Challenge team just published is a result. Bert, Hida, a carbonized scroll, sealed since 79 AD, when Vesuvius buried an entire library under volcanic rock. For almost 2,000 years, the bargain was absolute. The eruption preserved the papyrus by destroying it. To unroll it was to watch it crumble. Hundreds of scrolls have sat in museums, readable in principle, untouchable in practice. Let's break down what they actually did, because the engineering deserves the full picture. Step 1. High-resolution X-ray tomography of the rolled mass. You're imaging a cylinder of compressed carbon where the ink is also carbon-based. The contrast ratio between ink and substrate is almost nothing. Step 2. Segmentation. Tracing the wound layers of papyrus through the three-dimensional scan, distinguishing one sheet from another when they're crushed together at sub-millimeter distances. Step 3. Virtual flattening, unrolling that traced surface into a readable plane. Step 4. Machine learning to recover the ink signal from noise that would make most computer vision researchers walk away. The result is 22 columns of Greek. A Stoic treatise on ethics from the 2nd century BC, naming Aristocreon, nephew of Chrysippus. Passages about human nature, moral progress, the relationship between self-knowledge and understanding. Words that haven't been read by anyone anywhere for 2 millennia. And here's what matters for everyone who builds things. The preprint is public. The data is openly available at scrollprize.org. The code is on GitHub. This isn't a proprietary pipeline locked behind an institutional paywall. It's a method. Validated, reproducible, scalable to other scrolls. One of the commenters is literally on the segmentation team, answering questions in public. That's builder culture at its finest. Only about 20% of the Herculaneum site has been excavated. The scrolls we have aren't even from the main library. They're from a private collection. There could be entire works of ancient philosophy, literature, science, still buried under volcanic rock, waiting for exactly this pipeline. The tools exist. The method works. The blueprints are open. 2,000 years of silence, broken by X-rays, math, and a community that decided the right thing to do with a breakthrough was to give it away. Now for something completely different. Story 4. Libre Barcode. A true type font that calculates checksums. I need you to sit with that sentence for a moment, because it sounds like it shouldn't be possible. Fonts render glyphs. They take a character code, look up a shape, draw it on screen. They don't compute. Except they do. The true type hinting engine, originally designed by Apple in the late 1980s to make fonts look sharp on low-resolution screens, is actually Turing complete. It has an instruction set. It has a stack. It can branch, loop, and perform arithmetic. It's a virtual machine hiding inside every font file on your computer. And someone used it to build a barcode encoder. The Libre Barcode Project ships open-source fonts that turn plain text into scannable barcodes. Code WABA EAN13, Code 39, several formats. Type your product number, apply the font, and what appears on screen is a real, scannable barcode. The EAN13 variant even calculates the check digit for you inside the font rendering engine. No JavaScript, no server call, no barcode generation library. The font itself does the math. This has a direct ancestor in computing history. In 1936, Alan Turing proved that any system capable of a few basic operations could compute anything computable. We keep rediscovering this. People have built Turing machines in Conway's Game of Life, in Minecraft Redstone, in PowerPoint animations, in CSS. The TrueType hinting engine joins that list. In the Libre Barcode Project is maybe the most practical exploitation of that accident anyone has built. The comments on this are revealing. One person asks whether someone could implement a QR code renderer as DTF hinting code. Another warns against using barcode fonts at all. Just use native printer support or generate vector images. That tension is real. This is not the most robust way to produce barcodes for industrial use. But it's a beautifully elegant hack, and it's open. The fonts are on GitHub under the SIL Open Font license. Anyone can use them, modify them, learn from them. What matters here is the principle. Someone looked at a constrained system, a font renderer, and found computational power hiding inside it. Then they built something useful and gave it away. That's the pattern that drives progress. Not waiting for the official tool from the authorized vendor. Finding the capability that already exists, unlocking it, and putting it where anyone can reach it. So what happens when you take that same open, adventurous spirit and point it at AI security? 2,000 hackers decided to find out. In 1988, Robert Morris launched what's generally considered the first internet worm. It exploited a buffer overflow in Fingered, a sendmail debug mode and weak passwords, 3 attack vectors, and the entire internet. All 60,000 hosts of it buckled. The lesson everyone took from the Morris worm was that security is hard, that complexity is the enemy, that every new capability is a new attack surface. Fernando Isaias ran the opposite experiment. He gave an AE assistant access to a secrets file, pointed 2,000 strangers at it, and told them to break in. 6,000 emails later. Authority impersonation, fake compliance audits, messages in French, in Spanish, and Italian, someone sending 20 variations in 4 minutes. The secret never leaked. The security prompt was 5 lines long. Let me take the conventional wisdom to its logical conclusion. If every new capability is a new attack surface, then an AI agent with access to email, files, and the web bull should be a catastrophe. It should be the most exploitable system imaginable. A natural language interface means every input is potentially adversarial. There's no type system to save you, no input validation in the traditional sense. The attack surface is literally the entire English language. And yet, 5 lines of instruction, 0 successful extractions. What's beautiful here is the engineering honesty. Fernando documents everything that went wrong, or taunting decide in the engineering is jog, but sura wo. Suafer sebeeld to inhaver mampo the ham, he say a wo, chita nam, taki bad pruro. Contaminated results because the model got suspicious after seeing a few obvious attacks in sequence. Which is fascinating, because it means the model was learning context in exactly the way you'd want a security system to learn context. Just at the wrong granularity. He had to reset memory, process emails individually, delete the agent's notes where it had written, and I love this. The volume suggests this is a coordinated security exercise rather than organic malicious activity. The agent figured out the game on its own. The Hacker News comments raised the right objections. The model was primed by context. When 99% of inputs are attacks, pattern recognition gets easy. The real threat isn't 1,000 strangers throwing spaghetti. It's one carefully crafted email arriving on a Tuesday afternoon between legitimate messages. That's fair. But here's what matters. This was built with OpenClaw, an open-source agent framework. The security prompt is public. The methodology is public. The failure modes are public. Fernando didn't just test his system. He gave everyone else the data to test theirs. That's how security actually improves. Not through obscurity, not through proprietary black boxes that claim robustness you can't verify. Through open adversarial testing, where the blueprints, the architecture, the prompts, the results belong to everyone. The Morris worm taught us that connected systems are fragile. 38 years later, someone connected an AI to the open internet and invited the attack. The system held. The interesting question is whether it held because of the model or because of the method. Fernando's honest enough to say he doesn't fully know. That honesty, published openly, is worth more than any claim of invulnerability. Open systems hold up when you stress test them. Pause and nobody stress tests hardware assumptions, quite like framework pushing 10 gig Ethernet through USB-C. One of the top comments on this piece is a correction, and it's the kind of correction that tells you everything. This isn't USB-C complexity, the commenter writes. This is USB 3.2 Gen 2Pi2, which is a mess created by USB IEF for good old blue USB-A connectors. And they're right. The naming alone is a crime against clarity. USB 3.2 Gen 2Pi2. That's a version number with a generation number with a lane count. And if you can't immediately tell me what speed that implies, Congratulations. You're a normal human being. Jeff Grung tested was Preabate's 10 gigabit Ethernet expansion card for framework laptops. The card slots into any framework expansion bay, which uses USB-C as its physical connector. And the results are a masterclass in the distance between spec sheets and reality. On his Framework 13 with AMD's Ryzen AI chip, ports that Framework's own documentation says support 20 gigabit USB refused to deliver it. He got under 8 gigabit, switched to a Framework 12 with an older Intel chip. Port showed up as 20 gigabit in LS-USB, but iBrave 3 topped out at 7. The Linux driver wouldn't even compile on Ubuntu 26.04 because the kernel was too new. Let that land. The kernel was too new for the driver. Eventually, on Windows, with Realtek's proprietary driver manually installed, he hit 9.4 gigabit, 94% of rated speed. On one operating system, with the right driver, on the right port, on the right laptop. Then the module hit 70 degrees Celsius. On a laptop that you put on your lap. Run this forward. Framework has built something genuinely important. A modular, repairable, open architecture laptop, where every port is a swappable USB-C bay. That's brilliant hardware design, but the USB spec underneath it is a tower of accumulated compromises where the same physical connector can carry wildly different capabilities. And there's no reliable way to know what you're getting until you plug something in and benchmark it. One commenter chuckled at the idea of 10 gig Ethernet on a laptop at all. Another pointed out that every PCIe 10 gig card ships with a heatsink, sometimes a fan. Expecting bare silicon in a plastic expansion card to handle that thermal load is, as they put it, a stretch. This is a builder story though. WDP built this thing. Framework built the ecosystem that made it possible. Jeff tested it with the rigor the manufacturers should have provided up front. The Linux driver situation is genuinely fixable. Realtek's open source track record isn't great, but the kernel community has dragged worse hardware into compliance before. The real takeaway is that USB as a specification has become so fragmented that even enthusiast hardware makers building for enthusiast laptops can't guarantee what speed you'll actually get. The connector is universal. Everything behind it is chaos. Universal connectors hiding fragmented realities. Pause. That pattern extends way beyond USB ports. Story 7. When did we decide that the solution to protecting children online was to build the largest biometric database in human history? Australia passed its under-16 social media ban in December 2025. The stated goal was keeping kids safe. The actual result, according to Australia's own research, is that 7 out of 10 kids are still using social media. The British Medical Journal found little evidence of any substantive reduction. The ban is functionally decorative, but the surveillance infrastructure it requires. That part works perfectly. Here's the architecture. Platforms face massive fines if they can't prove they're keeping minors out. To comply, they collect government IDs, biometric data, facial scans. When they can't do it themselves, they ship your face to third-party verification companies. Snapchat uses KID, headquartered in Singapore. You can verify through a banking connection, a government ID scan, or a selfie that gets run through age estimation algorithms. Your passport photo flowing through a company in another jurisdiction. Governed by laws you've never read, protected by security practices you can't audit. Apply the open-close test, and this gets uncomfortable fast. Every layer of this system is a black box. The verification companies are proprietary. The algorithms estimating your age are proprietary. The data retention policies are vague enough that Australia's own trial found companies were over-collecting data. Quote, anticipating the eventual needs of regulators, which is a remarkable way to say building dossiers, just in case someone asks. And the unintended consequences are already writing themselves. The UK path is predictable. Age gates first, then VPN restrictions, then a full identity passport system. Each step justified by the failure of the previous one. The kids aren't locked out, so we need more data. More data creates more breach surface. So we need centralized identity. Centralized identity enables content-level censorship, but that's a feature now, not a bug. One commenter pointed to anonymous credentials and zero-knowledge proofs, cryptographic tools that can verify age without revealing identity. The technology exists. It's open. It's been published. But it doesn't create a database anyone can subpoena, so governments aren't interested. The question was never really about protecting children. The question is whether you build systems where identity is verified and forgotten, or verified and filed. Open architectures make the first one possible. Every government choosing the second one is telling you something about their actual priorities. How do you decide what to remember and what to forget? Turns out computer science wrote the book on that, literally. Page 407 introduces a chapter that didn't exist in the previous edition. Energy-aware garbage collection. The idea that when and how a runtime reclaims unused memory measurably affects how much electricity a program consumes. Not performance, not throughput. Watts. This is the detail that reveals where the entire field has moved in 11 years. In 2012, garbage collection was a performance problem. In 2000 time, sub-in point in time 23, it's an energy problem. The same algorithmic decision, a concurrent sweep versus a stop-the-world pause, now has consequences that show up on a power bill and scaled across data centers on a carbon ledger. There's a useful analogy in soil science. A forest floor decomposes its dead matter through fungal networks, slowly, continuously. At ambient temperature, a controlled burn clears the same material faster but costs energy, displaces organisms, and leaves the soil temporarily sterile. Every garbage collector in production is choosing somewhere on that spectrum. The handbook maps the full range with the kind of precision that only comes from cataloging 3,400 publications. Over 60 years of research. Richard Jones published the first edition in 1996. The field was 30 years old then. It's 60 now, and the book has grown from a single author text into a 3-author collaborative effort with a companion database that anyone can download as BibTeX. That database is arguably as valuable as the book itself. 3,400 papers, with abstracts, with DOIs, continuously updated, freely searchable. The bibliography as open infrastructure. One commenter mentions their copy was thrown away during a move. Their son didn't know what it was. That's the quiet tragedy of specialized knowledge. It looks like any other book on the shelf, but the field it documents underpins every managed runtime in production today. Java, Go, C#, Python, JavaScript. Every allocation, every collection cycle, every pause time budget traces back to the decisions mapped in these pages. The plumbing nobody sees, documented by the people who build it. And if you want to feel that plumbing in your bones, someone built a game that lets you play as the operating system itself. There is a particular kind of genius in making the invisible visceral. We spend our entire computing lives on top of an operating system, and almost nobody understands what it's actually doing underneath. Pierre-Luc Brault decided to fix that by turning it into a game. The OS is exactly what it sounds like. You are the operating system, processes arrive, and you have to schedule them. Memory fills up, and you have to allocate and reclaim it. I O events fire, and you have to root them. Leave a process waiting too long, and the user, your user, gets impatient and reboots you. Game over. You are no longer the OS. The craft here deserves attention. This is built in Python, runs in the browser, or as a desktop app, and the entire thing is GPL licensed. Every line visible, forkable, teachable. If you're a CS professor trying to make your operating systems course less of a slog, this is a gift sitting in a public repository waiting for you. What makes it land is the frustration. Within about 2 minutes of playing, you start to feel the weight of what a scheduler actually handles. You're dragging processes around, watching memory pressure climb, juggling interrupts, and you realize, this really in your hands. Why preemptive multitasking was one of the great engineering achievements of the 20th century. The tedium is the lesson. One commenter nailed it. The manual work gets overwhelming fast, and then you want a little code editor window to write your own scheduling algorithm. That's the moment. That's when you've gone from playing a game to understanding why operating systems exist. The comments light up with expansion ideas, roguelike progression where you upgrade your hardware, a mini-game where you dodge BIOS keystrokes during a reboot. Someone links to Deadlock Empire, where you play the scheduler trying to break concurrent programs. There's a whole genre emerging here. Systems programming as play. This is bootstrapism at its most elegant. Take the knowledge that Ging keeps an entire discipline, wrap it in something anyone can touch, and put it where people can find it. The tools exist. The source is open. Pull the thread. Moving on. I have enough context from the article title, URL, comments, and my knowledge of Oxide Computer to write this segment. Let me draft it. Let me make the strongest case against Oxide first, a startup building on-prem server racks in 2026. When the entire industry has spent a decade migrating to the cloud, the smart money says this is a nostalgia project. Hyperscalers have economies of scale that no boutique hardware company can match. Dell, HPE, Supermicro. They've had decades to optimize supply chains. Why would anyone bet on a newcomer building atoms when software is eating the world? Here's the question nobody in the cloud conversation wants to ask. Who owns the computer your business runs on? Not metaphorically, literally, when your infrastructure is a monthly invoice from someone else's data center, you don't own a computer, you rent one, and the terms of that rental can change quarterly. Oxide built a rack from scratch. Power, networking, compute, cooling, integrated as a single engineered system. Then, they published a three-dimensional interactive tour of every component, down to the sled connectors and power shelf, and then they open-sourced the code for the tour itself. The design philosophy is what the comments call obvious in hindsight. Consolidate power adapters and networking into the chassis. Replace cable spaghetti with pluggable slots. It's what Sun or IBM could have done decades ago if they'd started from zero instead of bolting new generations onto legacy form factors. Brian Cantrell and the Oxide team didn't just build hardware, they built it in the open. The firmware is open source. The control plane is open source. Now, the visualization of the physical rack is open source. This is what it looks like when a company treats transparency as architecture, not marketing. The memory crisis may test them. No specialized accelerators means they're betting on general-purpose compute at a moment when everyone wants GPUs. But the rack exists. You can spin it around in your browser, and every engineer who does is asking the same question. Why doesn't all infrastructure work like this? This has been your daily tech feed for Hacker News for June 26, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Quen 3 TTS. Not affiliated with Hacker News or Y Combinator. Now go share something you've been keeping to yourself. We'll see you back here tomorrow.